Okay guys, here we are. I'm going to work out the solutions for you. Hopefully you've tried as many as you possibly can. Let me remind you that I'm going to work really quickly through these because I assume you've already tried them yourself, and I'm going to go really as quick as I can, and hopefully I don't make any mistakes. But if there's any question, feel free to pause. Feel free to just put a star by it, and we'll talk about it in tutorials. Really, whatever works best for you. Okay, so sometimes I'll talk through these, and sometimes I won't, because sometimes it's more beneficial for me to just kind of quickly go through this problem, and so you can see if you did it right as well. So I'm a big fan of showing all of my work, okay? What is that, 36? Because if you don't and you mental math everything, sometimes things get messed up, okay? Now, does 16 go into 32? I don't think so, but I'm going to do this and then reduce that. So let's see, 8 goes in there, right? That would be 4. Oh. Never mind, 16 does go into 32. Silly me. Okay, so I'm getting -2 for my answer, okay? Number 2. All right, number 2. And actually, I'm not going to write this whole problem down. I'm just going to distribute as I go, just to save even more time. And that was supposed to be a V. There we go. V equals. If you don't like the variables, feel free to not even do the variables. -120, and then that's a plus 9v. You can change it to x or whatever you want. You know, you don't have to use the same variables that the people use. I'm going to go ahead and move the 7 to the other side, and I'm going to bring these other guys over. So I've got a -141v once I bring it over. So -141 and a +14. 31, that would be a 27, I think. And then minus the 7 over. Oh, isn't that lovely? Okay, awesome. Number 3, -7 minus 7x. Make sure you're distributing the negative to both terms when you do this. I'm going to move this to this side. I'm going to move that to that side. And so x equals 9. And then with number 4, this looks especially fun. Let's distribute this. -63 plus 72x minus 48x minus 24 equals 2x. That was kind of written silly, plus 1. Okay, so I just kind of simplified as I wrote this problem down. Now I'm going to move all my x's this way, all my numbers the other way. So I've got... okay, I've got to think about this. Let's see. So let's see, minus a 2x, so that's a 70 minus a 48. Is that a 22x? Okay, and then I've got a -7. What is 63? That would be 787. So I'm going to add 87, and that's an 88. So x equals 4. Okay, that's not as bad as I thought it was going to be, but man, those are big numbers. Okay, and I'm trying not to use a calculator with y'all. This is the year of the you won't use a calculator that much, but I'm pretty sure Algebra 2, you also did not get a calculator all the time. So on these factoring problems and everything, I'm going to try to mental math as much as I possibly can. I show my steps, but I'm still doing a lot of the work in my head. Okay, and this is how I deal with negatives. I think I told y'all that on the video before. And the negatives are going to end up not even mattering in a problem like this. So we've got 6 and 1, minus 6, minus 1. So 6 and 1 are both the solutions. Number 6. Same thing. Let me take out a -3 here, and so that's going to be an x squared, -3 plus 5x minus 6 equals 0. And then when I factor that down, let's see, that's going to be a +6 and a -1. And this won't matter. No solution comes from a -3, but there'll be a -6 and a +1 that come out of this. All right, number 7. 0 equals, okay, I'm going to go ahead and factor a negative 6n out of that, and so I'm going to be left with an n plus 4 when I do that. Now, up here, no solution came out because there's no variable, but right here, there is a variable, so we're going to set this thing to 0 and get 0, then we're going to set this thing to 0 and get the negative 4. So hopefully you got both of those solutions when you did number 7. Okay, number 8, going to move that 20 over to the other side, and this makes it really nice. Should I use 2 and 10? No. How about 4 and 5? Minus 4, minus 5. And notice there's my variable change. Alright, feel free, like I told you, feel free to change variables during a problem. But, you know, at the end, just in case you have a really picky teacher, go back and write it with the variable that was initially given. Okay, just to cover your butt. Alright, number 9. Okay, this one you're going to love because the leading coefficient is a 7, and people hate these, right? Because we're so good at factoring if that's not there. I mean, if that's a 1. But when it's not a 1, it's like, oh my gosh, what do I do? Okay, here's what I do. I told you, I'm a guess and check person. So the only thing that makes 7 is 7 and 1. So that's my starting point. Now 56, I just start going with what numbers pop into my head. Like I know 56 is 8 times 7, right? So I kind of just work with putting an 8 and a 7 in these spots, and I foil it out in my head as I go. So like for instance, I know that if I put a 8 here and a 7 here, then I would be doing a 56 and a 7, and that definitely does not make a 4. So, and in fact, 4 makes no sense. That's a 41. And I just didn't copy it right. So sorry, that's a 41. But now that actually is awesome because if I put the 7 here and the 8 here, then I'll be doing a, when I FOIL it, I'll be doing a minus 49 and then plus 8. And that will give me that middle magic term. Now that I've got my 2 parentheses, you're setting each of these to 0. So the first one's going to give you that solution, and then that parenthesis, of course, will just give you a 7. So that would be how I would handle a problem where the factoring is not as much fun. Number 10. I'm just going to rewrite this in an order that looks pretty to me, which is about like that. And then I'm going to take that negative out of everything. And then I'm going to try to factor. Alright, so to factor this, same thing as before. I know that a 2 times a 1 makes that. I know that for a 3, the only option is 3 and 1. So I either need the 3 here and the 1 there, or vice versa. So to make a negative 5, I need both of these to be negative, because that's a negative there, and that'll make the last term positive. So how would I do this? 3 and 1 or 1 and 3? Well, doing a little backwards foiling in your head is going to result in, I think, this. Alright, now if you're unsure, just FOIL it out, right? So that's a 2x squared minus 2x minus 3x. Okay, good. That does work. Now you take each of these and set them equal to 0. So x would be, if I move the 3 over, that's a 3/2, and that's a positive 1. And those would be my answers. Okay, now number 11 and 12, we're into radical land. So with something like this, remember the first step is to square both sides. So when I square both sides, it just gets rid of the radical in this type of a problem. And then I solve it just like normal. Bring the p to the other side. Bring the 15 to the other side. P is negative 7. Now, go back and plug that in, and like I said, make sure it makes sense, because if I plug in a negative 7 to this one, I get the square root of negative 14 plus 15. If I plug in a negative 7 over here, I get negative 6 minus negative 7. Just make sure these are in fact equivalent and real. Are they equal? Are they real? This is a positive 1, so that's good. And this is a plus plus. This is also a positive 1. So that's a good solution. Just make sure you check it. Number 12. Same thing. I'm going to shut up and actually just do it. Alright, bringing that around, bringing that over. That one, I already can tell that'll be a positive 6. That will also be a positive 6, so that will work. Okay, and number 13, that was the fun little word problem type thing. The sum of the digits of a certain 2-digit number is 4. So the sum of the digits of a 2-digit number is 4. When you reverse the digits, you decrease the number by 18. What is the number? Ooh. Okay, there's a lot of ways to do this. So some of you just might work with it in your head. I think that I'm going to do it like this. I'm going to call the ones place an X, and I'm going to call the tens place 10 times Y. And so I'm going to write it as 10 times Y plus X equals 4. And then it says if you reduce, what does it say? When you reverse the digits, you decrease the number by 18. Interesting. Interesting. Okay. So whenever, I gotta think about this. Give me just a second. Okay. I'm not even going to do this with algebra because I don't want to. This is more of an SAT kind of problem that's thrown in there. So it's just sort of a mental think about it. And you know, if you're going to make up 2 digits that when you add them together they equal 4, I mean, you're pretty much looking at 1 and 3, 3 and 1, and 2 and 2, or I guess 4 and 0. So you could just kind of guess and check your way. It's one of these combinations. Now it says that if you reverse the numbers though, you're going to get a number that's 18 less than what you started with. Well, that gets those out of the picture because if you reverse them, it's the same thing. So let me try 13. So if I have 13, they do add up to 4. 1 plus 3 is 4. If I reverse them, is that number 18 less? No, it is not. But maybe if I go the other way, what if I did 31 was my starting number, then I reversed it, is 13 18 less? And the answer here is yes. So that means 31 must be our lucky number. So logic problem, kind of weird. On an SAT problem or anything, I always tell my students when I do SAT prep, don't make equations. If it's a short list of numbers, run through the combinations as quickly as you can to get your answer. Number 14, write in exponential form. Okay, so this is very much like the one in the notes. It's in the denominator, and I know nothing's labeled, but if there is nothing here, it's an automatic square root. That's something you probably learned last year. And if there's no exponent up here, it's an automatic 1. So this is really 7v to the 1/2 power, but since it was in the denominator, you need to put a negative on it. Okay? Now, number 15, same thing. It's a 5k, and it's got a 2 as the exponent and a 3 as the root, so you just rearrange it like that. 16 is now going the other way, okay? So the 4 definitely needs to come out here, so 3n squared. And the 1 can be here. You don't even have to write it. It's an invisible 1. It's actually a negative 1 though, so what does that tell you? Well, it tells you to move it to the denominator. So that should be your answer to 16. And then 17, same thing. It's a 1/2 power, so there's a 2 here and an invisible 1 there, which means you don't even have to write the 2 if you don't want to. I would probably write it just like that. Okay. That's it. Hopefully you got something out of this, and we'll go over more problems like it and any questions you had on this during tutorials.